So in this video we will cover Angular beginner to expert level. So beginner level, intermediate level and expert level answers. So what is Angular and how does it differ from AngularJS? So Angular is a front-end framework used to build single page web application. It helps to create fast and structured scalable UI applications, and AngularJS is the old version, so like Angular 1.x, like those things. And intermediate level, AngularJS is a JavaScript based and Angular is a TypeScript based. We are using .ts here and AngularJS.js, and it is a controller based, and in Angular we have a component based, and it has two-way binding everywhere, and in Angular we have a controlled data binding. It is better than AngularJS. The performance wise as well it is better, and not mobile friendly, so it is a responsive one, and mobile and enterprise ready friendly. And expert level answer is Angular is modern TypeScript based framework designed for building scalable single page application. Unlike AngularJS, which used controlled scope, Angular uses component-based architecture, RxJS, dependency injection, and optimize change detection, and make it more performant, testable, and maintainable. Angular architecture. So Angular follows layered plus component-based architecture. So browser calls it, and it will hit to component. HTML and TypeScripts we have there, and we have template and data bindings inside there, and it uses services for business logic and those things, and we have a dependency injection, and as well as RxJS plus HTTP calls we have to populate the data. And core building blocks is components, templates, services, dependency injection, routing, RxJS, observables. And what is component in Angular? A component is self-contained UI block with template HTML and logic TypeScript and style CSS. So component will be like this, and selector, we will have selector, template URL, export class, user component, name Vasant, and real-time example we have header component, product list component, like those things. And what is directives and its types? Directives modifies DOM, behavior or appearance. So types of directives, we have structural directives like ngIf, ngFor, ngSwitch. It can change the DOM structure. They add, remove elements from the DOM. And attribute directives. So like we have ng class and the ng style, and custom directives as well we have. So this will change appearance and behavior of the UI. So using the ng class we can make it active or inactive, like that. And component directives, we have component itself, it is a directive with a template. Every component is a directive, but not every directive is a component. What are the Angular modules? Why are they used? So in traditional way we will have ng module. So ng module will have these declarations, user component, imports, common module, and export class, user module, like that. And why modules we need? So we have this for like logical groupings and lazy loadings and dependency scope, separation of features. So like those purposes we will use this ng module. So modern Angular version 14 plus we have standalone components. So standalone components, modules are essential earlier, but today we have standalone components to reduce boilerplate and improve tree shaking. So modules means folder level container, old style. Standalone component means self-contained features like new styles and cleaner. So Angular modules is a logical boundary that groups components, directives, pipes, and services. So it uses Angular uses these modules to organize and load features previously. So declarations, we will have components belonging to this module, and imports features used from other modules, and providers services with dependency scope, injection scope, and bootstrap app sorting component. So this is the old side project structure. We will have a app module .ts. Inside that we will have, and below that we will have product component and order component, like that. And product module.ts will have this kind of product relevant things, product relevant imports and declarations, those things. So what is the problem with these modules? Why Angular changed it? So we have too much boilerplate. So more files, it will be like very complex to learn. Hard to trace the dependencies. Debugging is painful, very difficult, and lazy loading will become more complex. And then Angular introduced these standalone components. So component that does not belong to any module, it declares its own dependencies. So the key idea will be like component equal to the features plus dependencies. No middleman required, something like ng module. And this is the basic structure. We will have selectors and we will mention standalone and imports, and the template URLs, we will mention that all here. So in old module we will have a login component. On inside that we will have login component.ts, service.ts, and as well as login module.ts. In newer versions we will have login component.ts and service.ts. They have removed the login module.ts because those things already we have injected in our this ts itself. So we'll take one scenario, login feature. It's here we have this standalone and selector. We have provided imports, and for this demo we have added this template here itself. So this component can be lazy loaded and can be reused and can be independently tested. So it will be perfect for microservice UI mindset. So this is the standalone lazy loading. It is the modern way. So we have route, we have mentioned it, and we have path here, and we are loading a component, importing this component, and then we have added this login component. Let's see one small example for lazy loading. Let's see one small POC concept. Explain this how lazy loading working. So lazy loading means load a module only when it is needed, so not at app start. And this is the small POC structure, and we have app, home, and admin. In app we have component.ts, and home and admin we have components, and how the lazy loading works. So if you see this image, route change trigger, is the route loaded? If yes means route change trigger, if no means we will do the lazy load module. So create a home feature, lazy loader, and we have home routes.ts, and we have a admin feature, it is also lazy loaded, admin routes.ts, and app routing. So this is where lazy loading happens, and we have app inside app routes.ts. We have mentioned home path home and load children, like import home of home routes, and we have mentioned the path of admin, and as well as we have mentioned load children to load the admin routes. And inside app component navigation we have mentioned two options to load the home and admin. So what happens at this time? So app starts, only app module loads in the screen, and when we are clicking home code is downloaded, and then when we are clicking admin, so at the time only admin code will be downloaded. So we'll never visit the admin code is never load on the UI screen. So why this lazy loading is important? So without lazy loading, so there will be a large bundle size, slower the first load, so it will be bad for users. And using this we will get our app faster and load only required features, and best for our large apps. What is custom pipe? So it is used to transform data in template when building pipes are not enough for our own formatting purposes, so transforming purposes, like displaying some other custom logic. So pipes should be pure, lightweight and side effect free. So why do we need custom pipes? So built-in pipes are limited, like we will have a date, currency, uppercase, like those things. But in real apps we may need text shortening, status mapping, file sizing and search filter, like those things. So instead of writing logic inside HTML or component, we use custom pipes. So to create custom pipes, so we can generate a pipe something like that. We can provide this command ng generate pipe, shorten the pipe name, and it will create on file. So there we will have we have to import our pipe, and we have to create our class, and we have to provide the pipe name, pipe and name. Within that we can provide our name, pipe name. So within the class we have to import pipe transform, and then we should have the method transform here, and it will accept two parameters. One is value, so that is provided, and the limit, so number equal to 10, like that we are given. And then so here what we are doing, like we are returning value dot length if greater than 10, so we are slicing that to this limit. So to use that in HTML template we can use like this: description shorten to 20. So that means if it is more than 20, it will shorten to the 20 characters. So even we can create with multiple arguments. So pure pipe vs impure pipe. So this is also very important. Pure pipe, it is default, so it runs only when the input reference changes. It will be extremely fast and best for performance. So this is recommended in 95% of cases. And impure pipe means so runs on every change detections. So and it will be very expensive. So when it's needed, like array mutation, push, like DOM dependent values, external state, so those places might be, it will be helpful, and we have to avoid this unless unavoidable. Angular change detection. So what is it? Angular checks when the data changes and updates the DOM. How it works? So internally triggered by events, HTTP responses and timers, user interactions, like that. Angular traverses component tree, compares previous vs current values, and then change detection strategies. It will be default, checks entire component subtree, simple but slower for large apps. So change detection, it will be like change detection strategy will be default, on push, so it will be production standard, checks component only when input reference changes, event occurrence observable emits. So change reduction will be like change reduction. This is the syntax change reduction strategy on push. Let's deep dive into this change reduction. So it detects the changes in application state and update the DOM automatically. So how this works? Angular uses Zoom.js component tree traversal change reduction strategy. And role of this zone.js, like Angular patches the async operations like click events, HTTP calls, set timeout and set interval promises like that. And whenever any of change these completed, Angular is notified and change reduction cycle starts. So Zoom.js is the trigger mechanism. And change reduction cycle will be like this. Async event happens, something like click time or anything, and zone.js notifies the Angular. Here Angular means Angular engine, so that is inside zone.js Angular reference like that. And the Angular starts the change reduction from the root component in the DOM. So it checks the component class properties, template bindings. If any value was updated, so DOM will update it there, and that's it, cycle ends. So this is happens very fast and many times. Angular provides two strategies. Default strategy and change reduction strategy. Default, it runs on change reduction for components, all its children, on every async event. So this is easy but costly for larger apps. And then we have on push strategy. So it is production standard. So this, when it runs, input reference changes, event inside a component changes, observable emitted some values, and manual triggers. So it does not run on every cycle. So on push improves the performance by reducing unnecessary change reductions runs. So let's see a small POC how it works. A counter component with a default vs on push. So we have a component here, and we have added the template inside this component counter, and we have button click. So on the button click we are calling the event handler increment. Inside the increment we are increasing the count. So now CD runs across the whole subtree on push change reduction. So this is the default one. So we didn't mention any change reduction here, but here if you see we have mentioned on push change reduction on push. That means so it will work, but CD runs only for this component. So the on push change reduction, let's see some more detail about that. So on push actually means when a component uses on push, Angular says I will not automatically check this component on every async event. I will check only if I get a strong signal something changed. So here strong signal means Angular will not run change reduction for an on push component only if input reference changes. So reference changed here, but not for the same reference, and an event happens inside that component. So click event, like those things, click happened in the component. So Angular trusts it. So CD runs for that component. And observable emits. So when observable emitted new values, so new value emitted, so CD will run at the time. And as well as when we are triggering it manually. So these places the on push change direction will happen.